Hello, good morning, student. How are you? I hope you all are fine, happy, and very healthy at home. So, what did we discuss yesterday? Yesterday, we discussed about the peptide synthesis. For the peptide synthesis, what is the starting material used, and as we know that starting material used for the peptide synthesis is a alpha amino acid, and alpha amino acid contains two functional groups. One is a carboxylic group, another one is a amino group, and among these two, one is a more reactive over the another one. So if you we already learned there are 20 amino acids are present. So all these amino acids, suppose as a two amino acid react together, gives rise to a 4 different product, and when these 4 different products are obtained, there is the difficulty for isolation. We cannot get the pure, or we cannot get the desired product if you use as it is whatever amino acids are there, and therefore to get the desired product we carry out the reaction for protection and deprotection. Then for protection we will get the desired product. So far we have learned what are the group used for the protection of the amino group, or what are the group used for the protection of the carboxylic group, that we have learned so far. Let us discuss today the peptide synthesis. That is, for peptide synthesis, what we are going to discuss today, activation of COH group. And as we know that COH group is less reactive over the amino group. Now what are the reagents which can activate, which can increase the activity or the reactivity of the carboxylic group, that we are going to learn today. So the activation of COH group must be activated for the formation of peptide bond, right? And second point, activation is necessary for smooth condensation of NH2 and COH group. And third key point here, it can be done by acid chloride and acid azides, etc. These are the reagents. By using these reagents, we can
activate the carboxylic group. Let us see first one as an acid chloride. First point as an acid chloride. As an acid chloride, let us see first one. Let us assume that first one amino group is a protected, and as we know that there are different suitable protecting group. By using that you can protect that amino group. Let us see over here Z, then NH, CH, then you can call it here R, and C double bond OH, right? This is the protected amino group in a alpha amino acid. And if this one further treated with PCl5 or SOCl thionyl chloride in presence of base or PCl3, these are the suitable reagent which can replace OH group by Cl. And what is going to happen here? Look at here, N, Z, NH, then CH, R, then C double bond O, Cl. Now what we did here, we replaced the hydroxyl group by Cl. Look at here, the electrophilic nature of that carbonyl carbon in acetyl group is a greater, or if you compare the reactivity between carboxylic group and acetyl group is a more reactive over the carboxylic group, and therefore this group get activated, or we can call it, this is a highly active. It is a highly active group. It is highly active group, and this highly active group further, or for example, let us see here, this Z, nothing but we know that there are some of the protecting group. Let us see pH, then O, double bond O, CBZ group here, NH, then CH, R, C double bond O, then OH. This is a, instead of that Z, we have taken, here is a CBZ group, that is a benzyl carboxylic group. This we can call it as a CBZ. In short, we can write as a CBZ carboxy benzoic group there, and it is a suitable protecting group used for the amino group. Then it will be treated with PCl5. What do you get? You are going to get pH, then CH2O, then C double bond O, next one NH, then CH, it R as it is, C double bond O, only OH group get replaced by Cl, means that group is a activated group, and this group now this three line indicate as a equivalent. So this group we can write in this manner. So pH, then O, then this C double bond O, then here you can write N H, then here C H R, then this one C double bond O and Cl. For sake of cyclization, I am showing this, the same structure I am representing like this. Look at the lone pair which is present on oxygen atom. What is going to happen? They are going to attack on this carbonyl carbon, because this group is highly active in nature. This double bond revolving around it, and there is a departure of this chlorine atom. What do you get? You are going to get over here this pH, then O, let us see here C double bond O, here N H, then CH R, then you can write C double bond O, and this 5-membered ring formed over here. If you observe this structure carefully, what do you see over here? Look at the oxygen atom has 3 bond here, 1, 2, 3. Therefore, positive charge comes on oxygen atom. As I already told you that whenever the positive charge comes on the more electronegative atom, that species becomes highly unstable in nature, highly unstable, and therefore what is going to happen next one, the chlorine atom which is departed from here, this Cl minus is going to attack at the benzylic carbon atom, and this positive charge get neutralized. So what do you get in the next case? This pH CH2 pH, then CH2 Cl, benzyl chloride you are going to get, and the 5 membered ring which you are going to get here, C double bond O NH, then O here, then C double bond O, then this one CH and R. This type of the compound is known as N-carboxy anhydride. This is known as N-carboxy anhydride. N-carboxy anhydride. This type of the species is formed here as an acid chloride. Look at this representation of this, how this anhydride, as we know that acetic acid, anhydride means C double bond O, C double bond O, C, means this is a acetic anhydride. Similarly here carbonyl group, oxygen and carbonyl, and this group is known as a N-carboxy anhydride group. So in this way this get protected as an COH group. Now let us look at as a second point over here. The second point of the discussion, because we are discussing about the peptide synthesis, there are various groups which can protect and we can get the desired product for the peptide. During the peptide synthesis, COH group is not activated as C double bond O Cl. So question may appear in your exam. So the question may be like, during peptide synthesis, COH group is not activated as C double bond O Cl. Why? Just now we have seen, right? And as we know that there are 3 key points why during the peptide synthesis COH group is not activated as a C double bond O Cl. There are 3 key points or key differences. You remember over here, C double bond O Cl is highly reactive and should not be activated as acyl chloride, right? That is one of the reason you should not convert that carboxylic group into C double bond O Cl, because it is highly active in nature. Just now we have seen how the anhydride get formed over there. Now second key point, COH group is generally converted into acylazide. This one, so what is the alternative? The alternative is that this group C double bond O group can be converted into C double bond O N3, that is a acylazide. This is, instead of this we can convert this carboxylic group into acylazide. The reason behind it, it is a mild leaving group.
Look at this one. Azide group is a mild leaving group and can be used during the peptide synthesis. Let us see that one as an acyl azide. So second point we are going to discuss over here, that is second one as acyl azide. As acyl azide, as we know that azide, right? Azide, N double bond, N positive charge over there. So that type of the structure, there is a resonating just like as a ozone molecule, there are 3 O3 molecule. Similarly, this also, as N3 means 3 nitrogen atoms are there. That's why it is called as a azide, and mainly it is nucleophile is a good leaving group, and whenever that leaving group and that leaving group should be the stable. Once it is departed, it cannot get recombined with the carbon atom. That are the some important feature or the characteristic of that leaving group. So now let us consider here again Z is a protecting amino acid, CH or C double bond O, OH, right? And this group can be treated with this protected amino acid can be treated with alcohol, that is R dash OH in presence of H plus. And as we know that it is a well-known reaction, this process is known as a esterification, right? This is known as a esterification, and esterification ester will be formed here, Z, then NH, CH, R, then this C double bond O, then O, R dash you can call it, right? That is the ester is formed. What we converted this acid group into as a ester, and then this ester further treated with NH2. Do you know the name of this compound? NH2 is known as a hydrazine. This is known as hydrazine, and this hydrazine, when this hydrazine is reacted with that ester, finally you will get the product NH, then CH, this R as it is, then C double bond O, NH, then NH2. This type of the compound you got, that is nothing but acid hydrazide. This is called as acid hydrazide derivatives you got over here, or we obtain acid hydrazide derivative over here. NH2 is reacting with that ester group, and we are getting as acid hydrazide derivative, and this acid hydrazide can be treated with with HNO2 nitrous acid, HNO2 nitrous acid or nitride over here. What do you get? This hydrazine group get converted into Z, then NH, then CH, let us see R over here, then C double bond O, and you can write as a N3. This group is converted into that azide. So we prepare the azide over here. Now this one further treated with the protecting group of that carboxylic group, C double bond O, then CH, here you can write R dash, then NH2 group. Now NH2 group is a free. This is a one of the what we can call it as a protecting of amino acid, and here is a activated by the carboxylic group. Now here protection of the carboxylic group, and there NH2 is a free to react, so it is going to react over there, and azide get departed over here. So what do you get? You are going to get here Z, NH, then CH, R, then C double bond O. Now this group NH peptide bond is formed over there, NH, then CH, R dash, then C double bond O, and Y is there. So in this way, here is a peptide bond is formed over there, or it is known as a peptide linkage, and the deprotection gives the desired product. After the deprotection will give the desired product. Deprotection will give the desired product. Deprotection will give the desired product. Means here you will get as a NH2, and here you will get as the C double bond OH. So this is about the as an acid azide, right? Now next one, let us see third point over here for the discussion of this one. Let me clean the board first, and then let us see over here, that is a third point. What is that? Formation of mixed anhydride. Third point, formation of mixed anhydride. Formation of mixed anhydride, that is let us see once again that Z protecting amino group CH, R, then COOH, this group as it is. Now it will be treated with ET thrice N triethylamine in presence of Cl, C double bond O, OET. The name of this reagent is known as ethyl chloroformate. It is known as ethyl chloroformate. The name of this compound is the name of this reagent is ethyl chloroformate. And this ethyl chloroformate, when treated with this protecting amino acid, what do you get? It remains as it is. Z, then NH, CH, R, that R remains as it is. But here C double bond O. Now this will pick up the proton. O get attack on this O, then C double bond O and OET, and now this group is highly, what we can call it as a mixed good living group. This becomes as a good living group, that is a mixed anhydride. It's a mixed anhydride because C double bond O, C double bond O, ET, and that type of the structure is called as a mixed anhydride. And when this mixed anhydride further treated with the reagent another amino acid like this one, H2N, then CH, R dash, then C double bond O, then that is Y, that is protected carboxylic group. Now what is going to happen? This is going to react with this, and the product you are going to get over here Z, then NH, CH, these are as it is, then C double bond O, this is going to react with this, then NH, peptide bond formation takes place, and then CH, R dash, then C double bond O and Y. This is a product we got here, and this in the and the what we can call it as the side product, maybe as a CO2 that goes in the atmosphere, and ETOH, ethanol, is formed during this peptide synthesis. Now let us see here one more example, one synthesis of simple tripeptide. Whatever we have seen, that is a dipeptide only. Now let us see the synthesis of simple tripeptide. Synthesis of here the example of, for example, first example, synthesis
synthesis of simple tripeptide. Synthesis of tripeptide. Tri means 3 amino acid get condensed together. We are going to get this one. Let us see, suppose is a here GLU glutathione or cysteine, and third one 3 letters I am using here, and the glycine GL1, right? And now what are those, how they get condensed together? Let us see here. H2N CH COOH, then CH2 COOH. This is a CH, not COH. Here let me write here C double bond O NH. There is a peptide bond formation, then CH, then CH2OH, then C double bond O NH, then further CH2 C double bond O. Glycine means CH2 C double bond O OH. Look at, this is a what we can call it the tripeptide. Tripeptide means here is a glutamine, then cysteine and glycine. You know that here H2N C double bond O CH2 C double, but here is a formation of a one peptide bond. Now look at this one, C double bond O, another peptide bond formation, because there are 3 molecules get condensed together. As we know that terminal one is here glycine, and this middle one is not I think here is not cysteine having a SH, not the OH. Please correct this, CH2 SH, not the OH. That is a cysteine. Cysteine, as we know that is NH2 CH2 SH C double bond O. R is nothing but CH2 HS. Okay. Now, and if you see this one, totally here you are going to get H2N, then CH, CH2 twice, COOH and C double bond OH. This is a glutamic acid. Then second one, when you break here, you are going to NH, CH, CH2SH cysteine, C double bond OH, and in this case there is a glycine H2N, then H2N, then CH2 C double bond OH. This is a glycine. These are the 3 structure combined together, and we are getting as a this type of the peptide synthesis, that is a tripeptides are there. Now let us see, first one is a glycine over here. Now first point is a glycine, as we know that H2N, then CH2 C double bond OH, glycine. Further glycine is treated with, suppose what is that, triethyl ester, that you are going to get H2N, then CH2 C double bond O. This will be treated with this one, C double bond O, in presence of H plus isobutylene, and we are going to get here CMe3, this type of the group. What we did, we protected the carboxylic group by using as this reagent, which is a suitable reagent for the protection of this. Now in the second case, let us see here. In the second case, what is happening? What is that second one? We are considering here is a cysteine. The structure of cysteine is this one. Then CH, CH2, SH, then C double bond OH. For cysteine, what we are doing? We are doing here First one is a esterification. Second point will be treated with hydrogen hydrate NH2 and third one with HNO2, right? What do you get over here? While adding all these reagents, esterification, their ester group, hydrogen acid hydrazide, you will get HNO2 means there you will get as this one. So in a one step you are going to get H2N, this CH, then CH2SH, finally here C double bond O N3. Acyl azide we are going to get over here. Now in the third step, what you are going to before that here before this esterification, first step here, let us remember here this H2N, then CH, CH2SH, then C double bond OH. First this one treated with benzyl chloride. What do you get here? BN, NH, then CH, H2, OH, then C double bond OH, and then you are going to get this one, and here is nothing but HBN. So this type of the product you are going to get over there, and after that you treat this compound with this one here, this one H2N, then CH2, C double bond O CME3, right? And after reacting this with this, what you are going to get? This is going to attack on this carbonyl group, revolving around it, and azide get removed, so that you are going to get here BN, then HN, then there CH, then CH2HS, then C double bond O, double bond O, and then NH, peptide bond is formed over there, then CH2, C double bond O, and C Me3. This type of the compound peptide we will get, and this or in short, this one further treated with minus 40 degrees centigrade. The reaction condition is kept over here, and then sodium in presence of liquor ammonia. This is the reagent used over here. What type of the product you are going to get over here? It will remove the benzyl group from over here, and finally it is this group get free. It is used for the deprotection of this group, and this one remains as it is here. So what do you get over here? Before that, let me here when we are adding BN is here, here yes, BN is converted when H2N CH CH2H. This group also get replaced by benzyl chloride, as well as this one hydrogen atom get replaced by that NH2, this also, and then here BN make the correction over here, and here after that you will get as a here BN benzyl group, and finally it will deprotect this as well as this benzyl group selectively, and you are going to get over here, that is H2N, then CH, then CH2SH, then C double bond O, NH, then CH2, C double bond O, C, Me3, and this is a compound you are going to get over, and this compound further treated with this one CBZ, then CBZ is used to protect the amine group, then CH, then here CH2 twice, then C double bond O, Cl, and here this is a C double bond O, Et. When this and this condense together, what you are going to get over here, you are going to get here, let me clean the board here, and here you are going to get, after combining here, look at here, this NH2 is going to attack on this, and you are going to get this one CBZ group as it is, then NH, then CH, then this one CH2, C double bond O, Cl, and further this C double bond O, N here, NH, then this one CH2SH, then C double bond O, NH, then CH2, C double bond O, C, Me3. This type of the product you are going to get over there, and after that finally first one is treated with PH4I, and first one, and second will be the hydrolysis, and after doing this, what do you get? You are going to get the final product is H2N, then this one COOH, then CH2, then C double bond O, NH, then CH2SH, and then finally C double bond O, NH, CH2, C double bond O, OH. This is a tripeptide. In this way we can synthesize this tripeptide by using this way. And next question may arise on this, on tripeptide, may be as a like this. So for example, suppose as a alanine, question may be as a alanine, then what is that? LIU, then third may be as a glycine, GLY. So this or maybe ILE, then tryptophan, then cysteine, or what is that? Glutamine, then aspartic acid, then cysteine, then maybe as a protein, then leucine, glycine, then maybe as a NH2. So nonopeptide means 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can remember that nano, that is oxytocin. This one is a oxytocin, and it is a hormone created by pituitary contraction of the clitoris. So I think with this we have seen the protection of this peptide synthesis, how the protection is carried out and how it is selectively synthesize the peptide synthesis that we have seen so far. So next point we are going to learn about the solid phase peptide synthesis in the next lecture. Let us stop today here. Thank you. Have a nice day.